Hi, I'm Kevin Hoyt, Platform Evangelist with Adobe. Welcome back to this series on RIA problems you never knew existed. In this segment, we'll talk about RPC spaghetti code. RPC spaghetti code. Well, what does that mean? Well, in the world of RIA and SOA, which kind of go hand in hand, you end up building up this really great user interface that makes these incremental requests for data along the way. That's wonderful. Now, making a request for a chunk of data is one thing, but managing that data intelligently is another, right? So let me give you an example. Let's say we have an entity in our database called person, employee, call it what you will, one entity. Now for that entity, regardless of its actual type, you're going to want to do a few different operations. You're going to create, you're going to want to read, you want to read a certain one, and then you're going to update that record and you're going to be able to delete that record. Right? That's generally referred to as CRUD, create, read, update, delete. Now, for every given entity, you're going to have those methods. And that seems great, right? Oh, I have an RIA. I can just call out to create a record. I can call out to read all. Yeah, but not so fast, because in an RIA, it's asynchronous. So you make the call to do that action, create a record, read a record, delete a record, whatever the case may be, and then you get the results back. What this means is that for any given entity, and all the CRUD operations on there, the 5 CRUD operations, that you have request methods and result methods for each. 5 CRUD methods, or 5 CRUD operations, asynchronously, 1 out, 1 in, times 2. 5 times 2 is 10. So for any given entity, you have 10 methods that you get to write as the RIA developer. Now you might be thinking, okay, that's not a problem. You know, I get paid to write this stuff. I can do 10 methods. That's not going to be a problem. Okay. Now what if your database is more complex though? I'm guessing you probably don't have just one entity. What if you have 10 entities? Well, 10 times 10 RPC methods to write equals 100 methods you have to write. Now that's getting to be a little bit more intimidating, and if nothing else, it's actually starting to really kind of get a little messy. You're going to have to architect that guy really carefully. Now, 10 entities, quite frankly, in a lot of systems is still really small. 10 is not very big. So what if you have 100? Well, if you've got 100, that times 10, right, out and back, for 5 different CRUD operations, that's 1,000 CRUD methods. Now you're no longer having fun writing a few different RIA methods. You are in over your head with work to do to code all those different methods. That's going to be a long time, and it's going to turn into a jumbled mess. Even if you try your best to architect it correctly, it's going to turn into a jumbled mess. So how do you fix that? Well, I propose you fix it by abstracting out the model from the view and let the model do all the operations on the data. Let me give you an example. Here we have 3 different elements. We have our model, our database, our entity, our database on the server, and then in the center we have our model on the client, and then on the right we have our viewable viewport or data grid or list or whatever it is you want to call it. Now, data comes out of the database and it fills the data model. Now, if you're using some of the techniques I mentioned in my other series in this particular lecture of RIA problems, then you've probably already, you can apply a lot of that here again as well. But let's say that we filled up our data model on the client. Now, the grid then, or the list, or the whatever it is going to use data binding. It's going to watch the data model for changes, so that when the data model changes, the view updates itself. That's a big step forward, because usually how we architect it is to actually take the data and put it into the view. We want to keep those things separate. Now with the model separate, when changes happen to the data in the view, they're actually happening to the data in the model. Changes on the model trigger a request out to the database gets updated. That's great. Now, what about when it comes back, right? Because that's our request all, do some changes and update the record. When we update the record, we have to get that result, right? Well, here's the twist. I propose that you only worry about the results when there's problems. All right, if there's a problem, then you want to deal with it. Otherwise, most of the time, you don't really care when you've got a result. So if you abstract this out into the appropriate architecture, your code can actually look a lot like this. And in fact, this is the core of what some of our Lifecycle Data Services product does. So if you look at, for example, here we have a new model. That gives us the model that we're going to put our data in from the server. We have a new person. That's going to be our entity in this case. And just by saying new person, if we've done the model correctly, we've essentially at this point gone ahead and created an entity in the database. We want to be able to fill up the view and read all the records. That's a fill. We want to be able to get a specific person from the database. That's a get item. Okay. And then we want to be able to set the values on that. Now again, if we set that on the model correctly, the model knows when the properties of those value objects change and can update the database accordingly. So person.last equals Hoyt is an update. We only worry about the results when there's a problem. And then the last one then again, model.remove item says get rid of this specific item from the model. When it does that, it's actually reflected on the server, and we only worry about the results when there's a problem. Now, if you look at this, what we've just done here is we've done all the work I just mentioned at the beginning of this session. We create a record, we read all the records, we read a specific record, we update the record, and we delete the record. But instead of having to deal with hundreds or even thousands of RPC requests and response, by architecting it correctly and being able to isolate the model from the view, we've really narrowed it down to just about 5 lines of code. It's a much easier way to go than to only have to worry about problems when they arise. So that's the essence of RPC spaghetti code and a quick tip about how to get around it. That's it for this session. I'll see you in the next sessions. Until then, I'm Kevin Hoyt.